The Scatterdice application is a prototype implementation of our Scatterplot matrix navigation technique. Scatterdice consists of four main components: a scatterplot matrix, a query layer control box, and a navigation bar. The main scatterplot visualization shows the current position in the scatterplot matrix. In other words, two of the dimensions in the dataset. A set of simple navigation techniques allow for controlling the position in the scatterplot matrix. The keyboard of the navigation bar can be used for stepping one position in the matrix at a time. Movement is performed as an animated 3D transition from one scatterplot to another, where one dimension remains constant. The user can also scratch the current position in the matrix to see the animated transition from one dimension to the next. To move directly from one part of the scatterplot matrix to another, it is also possible to perform a hyperjump. If the user wants to see the intervening positions, the path planning interaction transitions automatically from one position to another. Finally, path drawing allows the user to draw the path to traverse on the surface of the scatterplot matrix. Scatterdice allows the user to build queries using the query layer box and a lasso tool, and then see how the queries distribute in other plots. The user can move an eccentric label lens on the plot to see the nominal names of the data points. This also works with query selections. Finally, the rows and columns of the matrix can be reordered, either manually using drag and drop, or automatically using the pairwise correlation of the dimensions. We will follow a user who is employing Scatterdice using a graphical tablet for smooth and easy interaction. After loading a dataset of 1033 cameras, the user first decides to look at the price distribution of the cameras and navigates to this position. He builds queries for the four different price ranges of cameras. He then moves right in the scatterplot matrix to study the release year of these four groups of cameras. Using the eccentric label lens, he is able to drill down into the dataset to see the names of the cameras. The user wants to study the weight of the cameras, and thus drags and drops the weight column next to the current column. He then steps to the right again. Wide and telezoom are important for our user, so he uses path planning to navigate to the corresponding scatterplot. The user next sculpts the red and yellow queries representing low and mid-budget cameras to include only those with high wide and telezoom ratings. Then the user drags the max resolution row next to the current row and uses scratching to see how the red and yellow queries distribute across the resolution axis. Unsatisfied with this exploration branch, the user clears all queries and returns to the price and resolution scatterplot. He builds a new query consisting of both of the low and mid-level cameras. He then sculpts the query to only include cameras with more than 3 megapixel resolution. He navigates to weight and sculpts the query to only include cameras that weigh less than 1,000 grams. And finally, he navigates to the wide and telezoom scatterplot again and refines the query to only include the best cameras. He moves to maximum resolution and selects the highest resolution camera. Inspecting it with the label lens, he notices that there are actually two such cameras. Looking at price, one seems to be a low-budget one, whereas the other fits well into his budget. A Leica VLux 1 camera for $529.